But now I enjoy it because it kind of grows on me. So this is a picture from my lovely island, and we have tons of waterfalls, and we actually have 365 rivers. So we're very water-based area, very rainforesty, very, if you like that kind of stuff, we should all go. I think we should all go like next week. Me too.
Are we excused from exam?
Yes, you are. No, I'm not there. Anywho, so I won't go too in depth the anatomy and physiology. You should have got that last semester. So this is again a section of bone showing you the different parts of the external part and some of the internal aspects of the bone. I believe this is just a short video. Did we ever resolve the sound?
No.
Okay. I don't know. There's two things I have a problem. I'm just going to stop here and say, why is the sound not working and what kind of contraption is this? So I guess I'll put that on my list. Can someone, who's the secretary?
Right here.
Could you send me an email that says IT problem? Because it irritates me. So I might not irritate anybody else, just like trash over here. I can't. I had to say that. Keep it moving. So the video talks about.
Would you like to try that again?
You want to try it again?
If you want.
The what?
If you want.
Oh, yeah, we can try it. I appreciate it.
Okay.
We're going to take a look at Mike.
You may have to do it. This is my teaching assistant. Okay.
We're going to take a look at the microscopic bone structure. We're going to start off with the largest magnification, and that is the picture down at the bottom of the right-hand side of your screen. Here what you see are bone cells called osteocytes, and they're housed in little spaces called lacunae. So in each lacuna, you find one osteocyte. You can also see a network of canals called canaliculi, and these allow for the osteocytes via processes, which are long extensions, to communicate with one another. Going to the next magnification, what you see here is a unit of compact bone called the osteon, and down the center you see it's called an osteonic canal or a Haversian canal, and in that you can see blood vessels and nerves. They're typically very tiny blood vessels and nerves. If you look closely at the top of the osteon, you can actually see the lacunae and the little network of canals from one lacuna to the next called canaliculi. Here you see the osteonic canals extending from top to bottom, right down the center of each osteon. And then you also see horizontal canals. Those are called perforating canals. And those have larger blood vessels and nerves, and they connect one osteonic canal to the next, providing for a blood supply for the entire bone tissue. There are two kinds of bone tissue pictured here. On the right-hand side, you can see compact bone, which is essentially a series of osteons cemented together. Very regular pattern. You can see the pattern, the circular pattern, it's easily recognizable. On the left-hand side, you see what's called spongy bone. Spongy bone is much less dense, and it doesn't have nearly as regular a pattern. On the far right, the tissue that's flat back is the periosteum, and that is the bone coating that is continuous largest of the blood vessels and nerves, and you can see that those blood vessels and nerve branch off either to the left or to the right, entering the bone tissue and allowing for the nourishment of individual bone cells. You can see on the very outside a thin layer that's called periosteum. You can also see that the bone expands down at the bottom and also at the top. These portions of expanded bone are called epiphyses. Each epiphysis is going to articulate with another bone, and that's why you can see a cartilage coating there that provides for that articulation, some padding in that articulation.
Thank you. Alright, so just sort of a brief review from last year.
Good day, everybody.
So I wanted to briefly go through a couple of cells that are very important to make sure you understand their function. And the first one is would be osteoblasts, and they're present on any bony surface. So that includes the endosteum, the trabecular, intercortical areas, and their job is to produce a bony matrix called osteoid. And they also initiate mineralization of this matrix and facilitate or initiate the resorption of this matrix by osteoclasts. So as you know, osteoblasts and osteoclasts work together to build and construct the bone. So this is an H&E section, this is the bone marrow, and these are your osteoblasts. And osteoclasts are sort of macrophages or multinucleated cells, and their job is for bone reabsorption. So again, this is bone marrow, and these are your osteoclasts breaking down bony matrix. We won't look at this video, but it's important to remember the difference between endochondral ossification and intramembranous bone formation. So remember that endochondral deals with the lengthening of the bone, so long bones especially, and intramembranous deals with width. So we can have both occurring depending on the area or the bone that we're looking at. Again, you should remember the process of endochondral ossification as well as intramembranous, and there are also videos available for that. I always had an issue remembering some of the process when I was in first year. Now we're going to look at some diseases of the bone, and we always try to start with some sort of abnormal development. And so these are considered skeletal dysplasias. And even though these are some breed specific, they're so cute, they actually is considered a congenital or sort of a malformation. But now they're sort of specific for these breeds. So what breed is this? It's a pug. What about this guy? Pekingese. And so they're considered brachycephalic breeds. And what's the definition of brachycephalia?
Smush face.
Smushed. Very non-scientific, but we all get it. A smushed face. So what's a smushed face? What do we say? Shortening of what? Maxilla and mandible. Right. Very good. And then there is the other term, prognathia, or also known as monkey mouth or saw mouth, especially we call that in horses, is when the mandible is longer than the maxilla. Now, can you see where this could be difficult to determine when we look at an animal? Unless you're very comfortable with the breed-specific sort of disposition, it can be hard to tell when an animal has prognathia. So this is a horse with prognathia, and you can see that in this picture. Brachygnathia superior is considered where you have shortening of the maxilla. So, who can tell me the difference between this picture. Let's see. In this picture. Oh, sorry. So what's the difference between Brachygnathia superior and Prognathia? Okay, maxilla. So if you're in a clinical residence, if you're in the clinic, can you tell the difference? Oh, yes. So I always want to remind you, some things are just academic. So you want to make sure you're familiar with the terms, but in terms of their clinical presentation, their wellness, their ability to function, it's pretty much the same. But this is important. So Brachygnathia inferior, when you have a shortened mandible, okay, so this one is pretty extreme. You could definitely see that. We do see these in red Angus, and we'll talk about this a little bit. And in some cases, it's actually caused by bovine viral diarrhea. So BVD, so you did virology last semester. So how do we get BVD? How are bovines infected?
Respiratory.
Okay, so they're different types, right?
Yeah.
Okay, good. I'm not hearing anything. I can't hear. So talk to me about the persistently infected, non-cytopathic. What do you know about that?
When the mom gets the cytopathic version and the foal is born with that. So the
Who's
foal,
talking? Who are you talking
so then the foal has the non-cytopathic version.
Right.
And they're persistently infected.
Very good. So what happens with the foal in utero? What can happen with the foal? What do we see? How about pass it to somebody else? Your neighbor. What's some of the lesions or diseases we see with the foals?
Cerebellar hypoplasia.
Cerebellar hypoplasia, we can get this as well. So Brachygnathia inferior, got a hand tab, I like that. And a lot of congenital defects can occur in that case. All right. So this is Brachygnathia inferior, where we have normal maxilla and a shortened mandible. Any question back there? No? Another congenital disease is hair lip or chyloschisis. And as you can see here from this animal, looking at the sort of the muzzle area. And we have that defect. Another important disease is palatoschisis or cleft palate. So this is a bovine with cleft palate. And how is that defined? What would you define cleft palate as?
Incomplete fusion of the palatal bones.
Right. And so what would be a secondary effect of palatoschisis?
Milk coming out of the mouth.
Very good. Have y'all done this before? Yes. Oh, lovely. So aspiration pneumonia, because they are going to aspirate how well do you think they're going to suckle?
Not very poor.
Very poor suckle ability because obviously of that large defect.
Dr. Kathleen,
Yes.
can you go back to the chyloschisis one?
Yeah.
So what exactly is going on?
I'm sorry, I was not. What exactly is going on? So look, think of the term hair lip. So I don't even think that's how you spell it. Is that how you spell it? No, it's like hair as a bunny rabbit. Hare. So you know how in a bunny rabbit, have you ever seen this in people? I think that's the best example.
It's like a cleft lip, isn't it?
Cleft lip, yes. So when during development we didn't have it fusing, so you expect to see a unified mouth. What we have here is a defect, and even these animals can't suckle sufficiently because they don't have the full formation of that sort of that the lip area. Okay. Everybody understand? It's hard to have a definition, and maybe I should have. And it's not hair, like hair. See, like right here, H-A-R-E, lip in a calf. All right, game time. Ooh, early farm break. No, actually, it's right on time. Do you know why I do this game?
To break the monotony.
Break the monotony. Someone please wake up. And monotony for me, because then I start, don't know what I'm talking about. It's for all of us. And also to get to know you. So now we know that Damali likes to do karaoke. Anytime someone's doing karaoke, we're going to call him, right? Yes, there we go. The next person is from Las Vegas. Okay, one person. From Las Vegas. I looked at this in Monty, but it's the other one. University, attending the University of Nevada, Reno. Has 5 siblings. The oldest is 30. Now,
30 years older than her?
Okay, I get it. Wow. Are you the baby? Wow. Okay. Wait a minute now. How old are your parents?
My mom's 60 and my dad's 70.
Gotcha. So I didn't get that when I wrote that. So I couldn't find a good picture. So the only thing I had was 5 siblings. But now I understand it a lot better. It makes more sense. So you're the youngest and you have a sibling that's 30 years older than you. Wow. Okay. So we kind of guess who this is already. Mommy. I love this picture. Awesome. Is this from graduation? All right. Next person is from Summerville, South Carolina. The only person from Summerville? Yes. Okay. Attended Clemson University.
That's university.
Trash.
Okay. I've never had that reaction for Clemson University. Because they're trash. Really?
Negative.
And so it was. So I was like, a what? In a what? And I teach Asian medicine, and I was like, I have no. Okay, a little bit. Showed an Araucana bantam rooster.
Oh yeah. We took a class and we had to show basically farm animals. It was stupid, but we had to take care. Basically, they wanted free labor. We had to take care of the and stuff. So.
Oh.
Anyways, but yeah. So basically, it was called Little North America, and he showed all the animals. And out of all the farm animals, his name was Esteban. He got hurt.
Esteban! Oh, you sent me a picture. So how do you show a chicken? Is it just stand
I was
there?
lucky. Mine was already trained. So he walked them on the table, and then you show like all of their like assets. So you would open their wings. I don't know. He was pretty boy, so.
I absolutely love that. I've never seen someone show chickens assets. Right. Lovely. So I never knew this about you. Awesome. So, with your friends, family, girl yelling there. And, oh, wait, I had another picture. What happened?
We are one.
No, I missed. There, it's going to show up somewhere else. I know I had another picture. There was a picture with you at a wedding, and I'm not sure.
Where she cut the cake?
Yeah, oh, is that what you happened? You looked very surprised. That's all I know. That's weird. That it disappeared.
Yeah.
It's going to show up when we least expect it. I'll try to save it somewhere. Okay, the next person attended UPR on Puerto Rico, my West campus. This took me 5 years to get that word. And interesting thing is plays the guitar. And that's all we got. Figure that one out. Okay, who do we think this is? Luis? Okay, who else?
That's it.
Okay. Luis. All right. Back to class. Ooh. All right, so we're still talking about some congenital defects. And this defect is called chondrodystrophia fetalis, and it's characterized by disproportionate body growth. And what does that mean, disproportionate? Meaning that the torso is of a normal consistency, normal length, but the limbs are shortened. So what happens is the interstitial or endochondral bone growth is abnormal. So if you think about it, that is responsible for limb development. So legs, long legs, not long legs, but normal size legs, whatever is normal. While the intramembranous or acquisitional bone growth is normal. So the width is normal, but the length is abnormal. Okay? And this is called chondrodystrophia fetalis. So some of the abnormalities include the limbs, cranial base, and vertebral column are extremely